Welcome to our demo series on Inventor Nastran and Frame Generator. In this 3-video series, we will present the workflow to create a cantilever beam using the Frame Generator, and then we will extend this workflow to run the simulation using the Inventor Nastran. We will present the general workflow to run the simulation when a model has been created using the Frame Generator. For this cantilever beam. Today, we will start with the model preparation and some insights on the bending stress and deflation formula for this calculation. So, this is the geometry of the beam that we're gonna analyze. So this is 460 UV67, and on the right hand side I show the different dimensional details that we're gonna use for the calculation of the bending stress and deflections. So in here we had a cantilever beam force diagram that shows this cantilever beam that is fixed in one end and with a load applied in the other end. In here we show the formula to calculate the bending stress, where sigma is equal to bending stress and m is the calculated bending moment, vertical distance away from the neutral axis, and the moment of inertia around the neutral axis. And in here we show a diagram that shows the distribution of stress for a cantilever beam. And this is the normal stress. So we will see that from the center of the beam, the stress is 0, and then over the center line, you're gonna have tension with the maximum value at the top fiber, and under the center line, you're gonna have compression with a minimum value at the bottom of the beam. So with the information provided, we have calculated the bending stress to a value of 115.82 megapascals. Now, in terms of the cantilever beam deflection, so if we apply a load at the end of the beam, that load is going to create a deflection. Yes, so that deflection is calculated using this formula, where is going to consider the applied force, the length of the beam, Young modulus, and moment of inertia around the neutral axis. So with the information provided, we have calculated that the cantilever beam deflection for these loading conditions, the geometry is 1.73 millimeters. Okay, so now let me show you the workflow to create this frame using a cantilever beam using the frame generator. So let's get into Nastran. Okay, so now we have the Nastran software. We're gonna start with creating a new file, metric. We start with a assembly file. Okay, and now when we have our assembly file, let's save it. Yep, so we're gonna save it in here. Okay, and the name is gonna be this one. Okay, and now we're gonna create a layout. That's the first step. Yes, so in frame generator, basically we're gonna have the different structural members, and they're gonna be represented but at the center line. So all of the center lines can be made using sketches, and they're gonna be the base to create this type of model. So we're going to metric. Yeah, let's give it a name in here. Okay, yep, this one, and that's gonna be the number 2, and let you change the folder to this one from here. So that's all. Okay, good. Yep. Okay. Okay. So now we are gonna open a sketch, and in that sketch we're gonna select this file, and from that file we will select a point, and we're gonna create a line. So that line is gonna be 1500 millimeters. Yep. Then we do enter, and that is gonna be our layout. That's all good. Okay, so now we go out from this level. We do save. Yes, and now we're going to design. Yep, so on design, we click on insert frame, and on insert frame, we will be selecting the specification of the bin that we want to draft. In this case, is that 460 UV67. We will select the line that we drafted, and we have defined our bin. So we just do click in here. There is this dialog box. There is these files that are created automatically, and we just do click on here, OK, and we save it. And here we have the bin that has been created using the frame generator. Okay, so that is all for today's video. So in the next video, we will cover the pre-processing and the preparation of the finite element model. So don't forget to subscribe and hit the subscribe button to stay updated. See you next time on the next video. Bye.